Okay, welcome back to lesson 28 about inverse trigonometric function, arcsine, arccosine, arctangent, arcsecant, etc. Let's go to do the problems for the inverse trigonometric functions that involve finding the derivative of some inverse trigonometric function and the integral of some inverse, not the integral of some inverse trigonometric function, the integral of some functions whose antiderivative are the inverse trigonometric functions, like this one, or like this one. Okay, let's go to do it. We start with the first one. The first problem says, evaluate the expression of arcsine of 0 without using any calculator. So you will write y equal arcsine of 0. So y is the number that represents arcsine of 0, but still we don't know what is the value y of arcsine of 0. So what we will do is we will apply the inverse function of arcsine both sides of the equation. So the equation will read like this. Sine of y will be equal to the sine of arcsine of 0. Now, sine of y will be, what is the sine of the arcsine? So the arcsine of 0, put it in some number. And the sine of this number, put it back on the number. So it's 0. The sine of arcsine of 0 is 0 because they are inverse function. So now I have to wonder, who is y whose sine is 0? And the sine of y is 0 when y is 0, because sine of 0 is 0, and the problem is solved. Now again we are going to do the same exercise. We have to evaluate r cosine of 1. So y is r cosine of 1. And we want to find the value of y. Who is y? R cosine, to see, r cosine of 1. And how I will do? Well, I will use the inverse function of r cosine. The inverse function of r cosine is cosine. So I will do like this. Cosine of y equal cosine of the arc cosine of 1. And what is the cosine of the arc cosine of 1? Arc cosine of 1, put the number as y. And cosine of y, put the number in 1. So they undo what the other do, because they are inverse function. So cosine of y will be equal 1. So now the question is, who is y whose cosine is 1? And the y whose cosine is 1 is y equals 0. So the solution is that r cosine of 1 is y, and y is 0. And this is the solution. So the other thing is to go to the graph, maybe to go to the graph of r cosine of 1, because I don't remember the graph of r cosine, I have to construct the graph. So the graph of the cosine of x is 1 when x equals 0, is 0 when x equals pi divided by 2, and the graph end in pi, because if I continue, will not be 1 by 1. If I decide to continue the graph, this point will have 2 points to go. So will not be 1 to 1, will not pass the vertical test. And I need for a inverse function to pass the vertical test. So this is the cosine of x. So the points that I have here, I have the point 0. Let me put this, sorry. I have this point, that is the point 0, 1. So the point 1, 0 should appear in the graph of the inverse function. The point pi divided by 2, 0 is this point, this one, and the point, this point, is the point pi comma minus 1. This is the 3 points of the function cosine. Where are these 3 points in the inverse function? Well, in the inverse function will appear like 1, 0, 0 comma pi divided by 2, and the other point will appear like minus 1 comma pi. Let's go to represent the inverse function. The inverse function of cosine of x of arc cosine of x. So this is the x. So when it's x equal 1, y equals 0. When x equals 0, is pi divided by 2. Pi divided by 2 is bigger than 1. Pi divided by 2. And when x is equal minus 1, the y is pi. So it's pi is here. So the graph will do something like this. This point, I suppose will do something like this. This is the graph of the arc cosine. And on this graph, I can see that when it's 1 here, when it's 1, arc cosine of 1 is 0. So I think it's okay. Let's go to the next problem. Now the third problem say, use a right triangle to evaluate the expression sine arctangent of 3, 4. Sine arctangent of 3, 4. And use a triangle. Okay. Sine of arctangent of 3, 4, this will be a number, an unknown number. Let's go to call this number zeta number. So the expression that I will have is sine of y equals zeta, where y is arctangent of 3, 4. Let's go to solve for who is y. To solve who is y, I will apply the inverse function of arctangent, that is tangent of y. So tangent of y will be the tangent of the arctangent, that is the inverse of 3, 4. And the tangent of arctangent will be 3, 4. So the tangent of y will be 3, 4. And now I think I can do the right triangle that they say. The triangle will be the tangent, the y, this is the y, the angle y, this is 3 and this is 4, because tangent of y is 3, 4. Perfect. And now what? Well, and now I have to find who is sine of y. I have to find the z, who is theta. Theta. So sine of y is theta. So I will look in the same right triangle. This is why he said to do it with a right triangle. The sine of y is the opposite divided by the hypotenuse, but the hypotenuse is 4 squared plus 3 squared square root, or 16 plus 9 square root, which is square root of 25, where is 5. So the sine of y is opposite divided by the hypotenuse. So this is the result. The sine of y is z. What we are looking is 3/5. This is the result. Okay, the problem is solved. Now let's go to practice the same technique with the triangle to find what is sine of arc sine of 4/5. So no sine, secant of arc sine of 4/5. This is equal to a number theta that I want to find, who is theta. So this is secant of y equals theta, where y is arc sine of 4/5. How I will find who is y? Let me apply the inverse function to arc sine. So sine of y will be the sine S-E-N, but I write S-I-N instead. Well, sine, let me write it sine in English. Sine of y equal the sine of the arc sine of 4/5. And the sine of the arc sine is 4/5. So the sine of y is 4/5. So my triangle will say this is the angle y, and the sine of y is the opposite. This is my triangle, this is the angle y, and the angle y, the sine of y will be 4/5. Opposite divided by hypotenuse. So this is 3 by Pythagoras theorem. This is a square root of 5 squared minus 4 squared. Okay, which should be 3. So now I have the sine of y. And what we'll do is to find what they asked me. They asked me for secant of y. So I will use my triangle. What is secant? So I have my triangle, so I have control of the problem because my triangle gives me the control of the problem, because now I have to find secant of y using my triangle. So secant of y is 1 divided by cosine of y equal. But in this picture, I can see that cosine of y is equal adjacent 3 divided by 5. So it's 1 divided by cosine of y, which is 5/3. So the result is that because c is secant of y, c is 5/3. And the problem is solved. Well, I suppose find the derivative of this function. So y of x is 2 times arc sine x minus 1. So what I do remember, but I'm not sure about that, if y is arc sine of u, what is the derivative of y respect to the x when u is u of x? The derivative of y respect to the x, the derivative of arc sine of u is let me remember, I think is u prime divided by square root of 1 plus u square. Perfect. Now this is 2 times. Okay. So it will be, let's go to name u equal x minus 1. So the derivative of u respect to the x is u prime, and it will be 1. So the derivative of y respect to the x will be equal to u prime, which is 1, divided by a square root of 1. I don't remember, is 1 plus u squared. Well, let's go to do it in a different way later on, and we check. Plus u squared. U squared is, I think it's minus here. 1 minus u squared. Minus u squared. I think. Well, we'll do it in a different way now, and we check. Minus 1 divided by 1 minus u squared. U squared is x minus 1 squared, and these two will appear here because the derivative will be like a product of two functions. The derivative of the first is 0 by something, plus 2 by the derivative of arc sine of x minus 1. And the derivative of arc sine x minus 1, by arc sine of x minus 1 is this. So this should be the solution, I think. I think so, but let's go to do it in a different way. Let's go to do it like we should do it, because I don't remember, I never remember these kind of equations. Okay, let's go to do it like this. Let's say that y is 2 times arc sine of x minus 1. So y divided by 2 is arc sine of x minus 1. Perfect. And now what we will do? Well, I want to find the derivative of y respect to the x. So I will make, first of all, I will use sine on this expression. I will use sine of y divided by 2 equal sine of arc sine of x minus 1, with the purpose to convert this right side of the equation into an x minus 1. So I will do sine of y divided by 2 equal the sine of arc sine of x minus 1. And the sine of the arc sine of x minus 1 is x minus 1. So I have that the sine of y divided by 2 is x minus 1. Now what I will do? Same technique. I will make the derivative respect to x on both sides of the equation. So I will take this equation, this one, I will make the derivative respect to the x. What is the derivative of cosine of y, of sine of y divided by 2? Is cosine of y divided by 2, perfect, multiplied by 1/2 multiplied by the derivative of y respect to the x. Oh, I have here the derivative of y respect to the x. This is what the problem is asking me. Who is the derivative of y respect to the x? So I will solve it for the derivative of y respect to the x. And now, on the right side of the equation will appear the derivative respect to the x of x, 1. The derivative minus the derivative of 1, 0. Okay. So, the derivative of y respect to the x is equal to divide by cosine of y divided by 2. Now there is a problem here. And the problem is that I expect the derivative of y respect to the x to depend not on y, on x. So I need to work a little bit more. And to work a little bit more is to have this expression in your mind. We did the derivative here, but we had, before doing this, the derivative, we have this expression. So we'll put this expression at one side. Sine of y divided by 2, very important to remember, sine of y is x minus 1. So I need to put it in terms, I need to put this expression, to write this expression in terms of x. How I will do? I have this help, that sine of y divided by 2 is x minus 1. The other relation that I have that I need to use is the trigonometric relation that say that sine square of y divided by 2 plus cosine square of y divided by 2, this is 1. And this will allow me to find cosine of y divided by 2. Why? Because sine of y divided by 2 is sine of the angle y divided by 2 is x minus 1. So here will appear x minus 1 squared plus cosine square of y divided by 2 equal 1. Then cosine square of y divided by 2 will be equal 1 minus x minus 1 x squared. So cosine of y divided by 2 will be the square root of 1 minus x minus 1 squared. And maybe I can work a little bit inside the cosine. So the derivative is already found. Is 2 divided by cosine of y by the square root of 1 minus x minus 1 squared. And now the question is this the same that the other thing? Let's go to check the other thing. The other thing is square root of 1 minus, is the same thing. So I found it. I saved my face. Okay, so I did the problem in two methods. The first one, maybe the easiest one, is to use the equation. And the second one is to use your brain and not to rely on memory. But definitely to remember these things is useful to avoid if y is arcsine of u, the derivative of y respect to the x is u prime divided by square root of 1 minus u squared. This equation maybe I should memorize. Okay, next problem. Now the next problem. The next problem is given y of x, like arc tangent of e to the x. What is the derivative of y respect to the x? Well, for sure there is an equation that I don't remember. I will look for this equation in the textbook after doing the problem and I will check. I'm sorry that I don't remember. So, what I will do? So y is, the number y is arctangent of the number x that I put. So the best thing that I can do is to disarm this. How I will disarm? Using tangent. Tangent y will be equal to tangent of arc tangent or e to the x. So the tangent of the arctangent of something is something. So the expression that I have is that tangent of y is e to the x. And the y, this y is this y. So if I found the derivative of y, doing the derivative of this expression respect to the x, I'm done. So the derivative of tangent of y is 1 divided by cosine square of y, or secant square, by the derivative of y respect to the x. So this is the derivative of the left side of this equation. And the derivative of e to the x is e to the x. So the problem is almost done. The derivative of y, being y arctangent of e to the x, is the derivative of y respect to the x. I can solve it from here, and is e to the x multiplied by cosine square of y. But now I have the same problem than before. Who is cosine of square of y expressed in terms of x? How I will do it? I will do it like this. I will do it using the trigonometric relation of Pythagoras theorem. Sine square of y plus cosine square of y is equal 1, and I will help myself with the relation that tangent y is equal e to the x. Let's go to do it to find cosine square of y. So what I will do to make appear on this relation, to make appear tangent, I will divide everything by cosine square of y. So the relation, if I divide this expression by cosine square of y, will appear tangent square of y plus 1 equal 1 divided by cosine square of y. I have it. And I have here on the other side cosine square of y. Okay, let's go to divide by cosine square of y. So dividing by cosine square of y will appear tangent square of y. Divide by cosine square of y will appear 1. And divide by the 1 by cosine square of y will appear cosine square of y. But now I know who is tangent square of y. It's e to the x. Oh no. Tangent of y is e to the x, but tangent square of y is e to the x squared, or e to the 2x. So the equation will be e to the 2x plus 1 equal 1 divided by cosine square of y. And this allows me to find cosine square of y, that is the one that I need to plug in here. So cosine square of y is 1 divided by e to the 2x plus 1. So now I have the derivative of y respect to the x. The derivative of y respect to the x is e to the x cosine square of y, or in other terms, e to the x multiply or divide by e to the 2x plus 1. This is the result. Now let me go to your textbook, and on the next page I'm going to find these equations to see if I'm doing right. Let me go, just a moment. And the equations are here. We need to use this equation, this one, this equation. We need to use this equation, okay? This equation. I suppose that if we use the problem say if y is equal arc tangent of e to the x, I think, of e to the x, who is the derivative of y respect to the x. And here the solution say that the derivative, so u is equal e to the x. So the solution is u prime e to the x divided by 1 plus u squared, e to the x squared. And I think it was the same solution than before. Well, much more faster this solution for sure. But difficult to memorize these things. I always get, well, let's go to see it. This is u prime, square root of 1 minus u squared for the arc sine. From the arc cosine, it looks that is the same expression with the minus sign. It means that at the point u, the slope of 1 is positive, let's say plus 2, and for the arc sine at the same point u, the slope is negative. You can check that this is true by making by plotting the functions and choosing a point u, and for the arc sine, the slope should be positive, and let's say plus 2, and for the other slope of the arc cosine, the slope should be negative and should be minus 2. If this is 2, this is minus 2. Okay, arc tangent of u is u prime 1 plus u squared. You should derive this equation. Try to derive this equation. Okay, arc secant of u. Maybe I ask you in an exam to derive this equation. I can not memorize this equation for sure. I will leave you for the test this equation if you want. Okay. Remember me to give you for the test. Let's go to the next problem. Okay, now according to what I have shown you in the formulas, it says that the derivative of arc secant of u is u prime divided by the magnitude of u by the square root of u squared minus 1. And let me check if this is correct. Yes, it's correct. I already checked it. So doing the problem using the formula, u will be 2x. The derivative of u respect to the x, which is u prime, it will be 2. So the solution to the problem, the derivative of arc sine, the derivative respect to the x of arc secant of 2x will be u prime, which is 2, divided by the magnitude of u, 2x, multiplied by the square root of u squared, which is 4x squared minus 1. And this is the solution in a mechanical way that I really don't like too much, so let's go to do it. Let's go to do it like we should do it. Okay, let's go to do it. So it's a little bit longer, so we have to check that this will be the result. So we start with y equal arc secant of 2x. and we need to find the derivative. The first things that we will do is to use the inverse function of arc secant. The inverse function of arc secant is the secant. So we'll write the equation secant y equal to x, equals secant of arc secant of 2x, which is 2x. Now the second thing that we will do is to make the derivative of y respect to the x of this expression. The derivative of secant y is tangent y secant y by the derivative of y respect to the x. So the derivative of secant y will be tangent y secant y by the derivative of y respect to the x. You can check that the derivative of secant is tangent secant. I think that you remember this. And the derivative respect to the x of the right side of this equation is 2. So the derivative of y respect to the x is 2 divided by tangent y secant y. Now the expression is in terms of y, but I wanted to have it in terms of x. But I have secant y is 2x, so I can put 2x here, and I have to find who is tangent y. So the derivative of y respect to the x will be 2 times divided by tangent y by secant y, but secant y is 2x. So the problem is to find who is tangent y. But we know that sine square y plus cosine square y is equal to 1. If we divide by cosine square this expression, it will be tangent square y plus 1 equal 1 divided by cosine square of y, which is secant square of y. And secant square of y is 2x squared. So tangent square of y is secant square of y minus 1. But secant of y is 2x, so this is 4x squared minus 1. So the solution will be 2 divided by tangent of y, that is 4x squared minus 1. Tangent of y will be tangent of y will be a square root of 4x squared minus 1. And be careful that this is valid when 4x squared minus 1 is positive. So it has a x value that you have to calculate. But let's go to leave it here. So it will be tangent y square root of 4x squared minus 1. What is inside there, square root have to be something positive. So 4x minus 1 have to be positive. So 4x should be bigger than 1. So x should be bigger than 1, 4, to make sense to this equation. Okay. Multiply by 2x. So the 2 will cancel. And the expression will be 1 divided 4x squared, 1 divided by x multiplied by the square root of 4x squared minus 1. I think that is the same thing that here. Is the same thing. I have to cancel the 2, okay? It's the same thing. So I didn't make a mistake. So you need to practice this method. Of course, that doing these things with the formula is much more faster, and If you can learn by memory, it's better, of course. Let's go to the next problem. Now we do problem number 8 that say find the equation of the tangent line of the graph y equal r tangent of x divided by 2 at the point 2 pi divided by 4. Okay, we'll do the same thing. We can use the equations, but I don't know the equations, so we solve it. We solve it like we should do it. What the problem is asking is, you have the graph of y equal r tangent of x divided by 2. So the r tangent of x divided by 2 is how it is. Wow. How it is the arctangent of x divided by 2. The arctangent of x is the graph of arctangent of x is this one. Is this one? This is what happened here? What happened? This one. Okay. Okay. Arctangent of x does like this, I remember, is something like this, is the inverse function of tangent of x, and this is pi divided by 2, and this is minus pi divided by 2. So it's asymptote to the y equal pi divided by 2. And what would be the difference with arctangent of x divided by 2? Will have the same shape. This is arctangent of x, will have the same shape, but it will be a stretch. It will be a stretch, a little bit more stretch, the graph. So let's go to call this variable x divided by 2, u. So this is the graph of arctangent of x divided by 2. If you take the x-axis to be x divided by 2. Okay, this is the graph. And the equations say at the point x divided by 2, at the point x equal 2, x divided by 2 is 1. So at the point 1, comma, pi divided by 4. Pi divided by 4. At this point, what is the slope? What is the slope? Or what is the equation of the tangent line? We need to find the slope. This is the problem. So let's go to do it. As I said, if you go to the formula sheet that we saw yesterday, a few problems ago, you can do it faster, but I don't know. I don't remember the formula. Well, let's go to do it. No, doesn't matter. So y is equal arctangent of x divided by 2. What you will do, I'm going to go a little bit faster. What I will do is I will apply tangent of y, and this will result that tangent of y is equal to x divided by 2. Now I will do the derivative of tangent of y. The derivative of tangent is cosine square of y. So it will be 1 divided by cosine square of y, by the derivative of y respect to the x equal 1/2. So the derivative of y respect to the x will be equal to 1/2 cosine square of y. And now, based that tangent of y is x divided by 2, I need to find what is cosine square of y. So how I will find? I use the trigonometry, the fundamental, the Pythagoras theorem, sine square of y plus cosine square of y equal 1. I divide by cosine square, so I would have tangent square of y plus 1 equal 1 divided by cosine square of y, And now, because tangent of y is x divided by 2, I will have this expression. I will have x squared divided by 4 plus 1 equal 1 divided by cosine square of y. So 1 divided by cosine square of y is equal to x squared plus 4 divided by 4. Then cosine square of y will be 4 divided by x squared plus 4. So the derivative will be 1/2 of 4 divided by x squared plus 4, or what it's the same, 2 divided by x squared plus 4. And the derivative of y respect to the x at the point 2, at x equal 2, is 2 divided by 2 squared plus 4, which is 2 divided by 2 squared is 4, 2 eighths. 2 divided by 8 is 1/4. So this is the slope at this point. And what I have to find is the equation of the rectilinear line. So the point x0, y0 is the point 2 pi divided by 4. 2 comma pi divided by 4. So the rectilinear line that they are asking me is y equal y0 plus the slope x minus x0. In other words, y equal y0 is pi divided by 4 plus the slope. The slope is 1/4 at this point, 1/4 by x minus x0. x0 is 2. So this is the equation of the tangent line to the graph r tangent of x divided by 2 at the point 1, at the point x equal 1. Okay, this is the equation. This rectilinear line is this line. Okay, this integral is, I remember, the integral of 1 divided by the square root of a squared minus x squared ddx. This is arc sine of x divided by a. So in this equation, the equation is the integral of 1 divided by the square root of 3 squared minus x squared. So the integral, the indefinite integral, will be r sine of x divided by 3 plus c. And the problem is solved. Okay. Okay, to make this integral is related, I think, with an arctangent, because it has the structure of something here, something in the numerator, u prime, and it has the structure a squared plus u squared, because if u is equal e to the 2x, now du is 2 times e to the 2x by ddx. So e to the 2x by ddx is here, okay? And it appears 4 plus u squared, e to the 4x. So u squared is e to the 2x squared. So e to the 4x, so it appears this structure for the integral. So the integral will be the integral of e to the 2x divided by 4 times plus e to the 4x ddx equal the integral e to the 2x by d dx, e to the 2x by d dx is 1/2 of d du. So 1/2 v du divided by 4 times e to the 4x. E to the 4x is u squared. And this integral is 1/2. I think this is arc tangent of u divided by a. But this is 2 squared, so it's u divided by 2. Now, u is e to the 2x, so the final answer is arctangent of e to the 2x divided by 2 plus c. And this is the final result. Okay, I hope this is the last one. I hope so. Well, let's go to do this one. This one we need to see this relation u prime 1 plus u squared. So how we will see? Name u equal cosine of x. So if we name u cosine of u squared will be cosine squared of x. So I will have here I will have the u squared. And the derivative of u respect to the x, the derivative of u respect to the x, the derivative of cosine of x is minus sine of x. So d du is minus sine of x d dx. So minus sine of x d dx is here, and 1 plus, so this is the integral, is the definite integral we have to take care, is the definite integral from x equal pi divided by 2 to x equal pi of what? Of sine of x d dx, which is minus d du, but the limit of integration, they are not this one. Let's go to find the limit of integration. d du, let's go to right first. The d du divide by 1 plus cosine squared plus u squared. And this integral is arctangent. Is arctangent, right? Yes. Is arctangent of u. Now the x, when x equal pi divided by 2, u is cosine of pi divided by 2, which is 0. When x equal pi, u is equal cosine of x, cosine of pi, which is minus 1. So the point of the integration is from pi divided by 2, from u equals 0 to u equal minus 1. Minus 1. Wow. So this is minus arctangent of u. I think there is a minus sign here. Okay, so it will be equal minus. Let me correct here. Is a minus 1, no? From x equal pi divided by 2 is the 0, the lower limit, and this is minus 1, the upper limit. So it's minus arctangent. So it will be minus arctangent of minus 1 minus arctangent of 0. Okay. And now we have to find what is arctangent of minus 1. So name y equal arc tangent of minus 1. So we'll apply tangent of y will be tangent of arc tangent of minus 1. It will be minus 1. And when the tangent of y is minus 1, is minus 1 when y equal pi divided by 2 plus pi divided by 4. When it's 120 degrees, the slope, the tangent is minus 1, and pi divided by 2 is 3 pi divided by 4, or 2 pi divided by 4 plus pi divided by 4, which is 3 pi divided by 4. So the equation will be equal minus 3 pi divided by 4 minus arc tangent of 0, and arc tangent of 0 is 0. Is 0. We see it, I think it was the first problem. So the area will be minus 3 pi divided by 4. I'm not sure about the minus sign. I'm not sure about the minus sign. I think that it should be positive, this area. Is, just a moment. My family is telling me to go to bed, but you check the sign, okay? So the result should be 3 pi divided by 4 or minus 3 pi divided by 4. Okay, check the number. I think, the last one, find the formula for the derivative of the inverse tangent function. So the arc tangent of x equal y, or y equal arc tangent of x. And this problem I have done in the previous problems, so you know how to do it. You make tangent of y equal tangent of arc tangent of x, so it will be the x. You make the derivative, etc., 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 and I have done before, so I'm going to bed. Good night. If you have some a question about any problem, please feel free to send me a text message or a WhatsApp message and let me know which problem, which lesson, and with pleasure I will redo it.